Hello everyone, welcome to the new series of this channel in which I will teach you electronics instrumentation and measurement. For instrumentation students, this subject is very important for GATE and engineering services also. But for electronics student, this subject is very important for engineering services only. Those who are preparing for GATE only, you can leave it because there is no syllabus for GATE examination for electronics student, and for electrical student there is only 2 to 3 marks for GATE examination, and it is very important subject for engineering service examination. Okay, so before deal with the syllabus of this subject, let me explain you what is measurement, why we study this subject, and what is the importance of this subject. You are doing lots of experiment in which you calculate the value of voltage, you calculate the value of current, you calculate the value of resistance. Based on the syllabus, you can find different parameters, compare all of them and get the desired result. For calculating those values, you need some devices, and to draw your data or to observe your experiment, you need to compare between the two values. All this type of study comes under the measurement, in which we calculate some parameters, compare them, and observe. After observing that result, we can give our result. Not only in the college labs, it is also applicable in the physical world. For construction of any building, measurement is very important. For not only the civil engineering, also in electronics, for calculating the value of voltage, power, all that kinds of stuff, measurement is used. So this is the whole scenario for measurement. Now, what is the syllabus of measurement in the competitive examination? The first, in which we study about error. This is the very first topic of the measurement. After that, we study this different devices, in which some indicating type of devices, some bridges. For bridge, we study both AC as well as DC, some digital instrument, CRO, and after that last topic is transducer. One point is to be noted that the transducer is the very important topic for this whole subject. Most of the question based on transducer. So let me start the very first topic of this subject, which is errors. What is error and why it is so important in this measurement topic? Let's see. None of the practicals or measurement is done with 100% accuracy. Some of the error is always there, right? Means if you want to calculate the value of voltage 2 volt, and if you measure with some measuring instrument, it will get 1.99 volt. So 0.01 error is there, right? Now there are different types of error present in measurement. The first is limiting error. What is limiting error? Let us understand with some example. Suppose the value of resistance, S stands for series resistance, 200 plus minus 5 ohm, right? If you purchase any resistance in the market, from the market, then this one is given 200 plus minus 5 ohm. Now what is plus minus 5 ohm? It means that the value of resistance is vary between 200 plus 5, that is 205 ohm, and 200 minus 5, that is 195 ohm. This is the limit of this resistance. This is called limiting error. Right? The value of the resistance is vary between 195 to 205 ohm. Exact 200 ohm resistance is not there. Some variation is always present in the resistance, and this is called the limiting. Now for calculating the limiting error, one formula is there in which limiting factor or limiting error is equals to absolute value minus true value upon absolute value into 100. This is the formula for calculating the limiting error, right? You can also write this formula in terms of measured value also, which is epsilon r equals to measured value minus true value upon measured value. Right? So do not write the definition of errors which is not used and not comes in the competitive examination. You have to focus in numerical only. Right? The next part of this limiting error is the sum and difference, multiplication and division. Means if R1 is 2 plus minus 5 ohm, R2 is 2 plus minus 3 ohm, then what is the value of R1 plus R2, R1 minus R2, R1 R2 and R1 divided by R2, right? You know very well that this is the limiting error. See, for calculation of multiplication and division, it is very easy, and for the calculation of addition and subtraction, you have to remember one formula. So let us discuss first multiplication and division. For multiplication and division, the limiting error is always add, means the epsilon r equals to plus minus 5 plus 3 ohm, right? And for multiplication means when you calculate R1 and R2, then it is 2 into 2 plus minus, and what is this? 8 ohm, means 4 plus minus 8 ohm. And for division, R1 divided by R2 means 2 by 2 plus minus 8 ohm, that is 1 plus minus 8 ohm. Simple, always you sum this to value for multiplication and division, and for the value of addition and subtraction, one formula is there, which is epsilon r equals to plus minus a upon a plus b epsilon r1 plus b upon a plus b epsilon r2. Now, what is here a and b? This is our a and this is our b. Means some resistance is a plus minus epsilon r1 and this is b plus minus epsilon r2. So for calculating epsilon r, what is a is what? 2 upon 2 plus 2 into 5 plus 2 upon 2 plus 2 into 3, right? Plus minus 2 by 4, 1 by 2 or 1 by, okay, 1 by 2 or 5 by 2. Have to solve. 2 plus 2 is 4, 2 by 4 is 1 by 2 and into multiply by with 5, it's 5 by 2 plus 1 by 4 and 3 by 2, which is equals to plus minus 8 by 2. And for addition, you simply add this two value, and for subtraction, you simply minus this two value, and the value of limiting error is plus minus 8 by 2 or plus minus 4 ohm, right? So this is the whole scenario for calculating the limiting error. You have to focus for numerical only. Do not try to learn the definition, just understand them. Now let me explain some more numericals based on the limiting error. Let us discuss some numericals. The first numerical is two resistors 100 plus 5 and 150 plus 5 are connected in series. The resultant error will be, if two resistors is connected in series, then resultant resistance R equals to R1 plus R2. Means we have to sum with this two resistors. So what is the limiting error formula? A upon A plus B into epsilon R1 plus A upon A plus B upon A plus B into epsilon R2. Right? So 100 upon 100 plus 150 into 5 plus 150 upon 150 into 100 plus 100 into 50. This is your resultant error, and the value of resistance is simply you have to add this to value, which is equals to 250 ohm. You can solve this very easy. Now let us come to the second numerical, in which the limiting error in the calculation of power will be. You know that the value of power is I square R. Here multiplication is used, but square is there. So what can we do when square is come, or power 3 or power 4 or some higher power is come? This is not a very big problem. Here epsilon R1 is 0.5% and epsilon R2 is 0.2%, right? And you have to calculate epsilon R. If simply I have to calculate IR, then we don't do nothing, simply add this to value. But in case of I square R, just multiply with 2 with this 0.5. Why? 0.5 into 2 plus 0.2. This is 1.2% is your final answer. But why we multiply by 2 with 0.5? See, in case of power I square R, those number is present here is simply multiply with the limiting error. If I cube r is there, then for calculating the epsilon r, simply you have to put 3 into 0.5. For I की power 4, 4 into 0.5. Understood? So this is not a very big task. You can calculate it very easy, and 1.2% is your final answer. Right? So this type of numerical is given in the examination, and both these two numerical was come in engineering service examination. 2 marks each. Okay, limiting error is completed. Now, for theoretical point of view, error can be divided into 3 types. The first is gross error, second is systematic error, and the another one is random error. Systematic error is again divided into the 3 types: instrument error, measurement error, and environment error. This is for your knowledge only. This is not asked in any examination. But which is this is in the syllabus, so let discuss one by one. First is gross error. Gross error is what? It comes with human error. Suppose I am doing some experiment and the value of my voltage is 1.0005 volt, but in my notebook I write the value of voltage is 1.005 volt. So I mistake for writing the value of voltage, and this mistake comes under the gross error. This comes due to the human mistake only. Fine. Systematic error is what? Systematic error is further divided into the 3 categories: instrument error, measurement error, and the environment error. Instrument error is what? Means your instrument is not working properly. It indicates the wrong value. Measurement error: instrument is correct, but you measure wrongly. It is related to the gross error also. And environment error is what? Some environment issues is there. Means some dust particle present in your instrument, or your instrument will damage due to some rain or some like other environment issues is there. So this all types of error are combined with systematic error. Random error is at random, any type of error present. You can minimize the gross error, you can minimize the systematic error, but you cannot minimize the random error. Random error is always there in any type of instrument, in any type of measurementing device. Right? This is the whole scenario of error. What is error? So the error part of measurement is completed. This is the very first and very basic type, and it is a very short topic. After that, we will discuss indicating type instrument. 3 type instrument is there in indicating time. What is that? What is the working principle of that instrument? We will discuss in our next video. So that's it for today. Thanks for watching this video. Thank you.